Okay, well, let's continue our 03 visualization one. The next topic we want to talk about is the log scale. And remember, just now when we see this visualization, we have already seen the log scale, right? That's, well, on the y-axis from 10 to 100, and then from 100 to 1000, and then the gap are the same. Well, the reason is the population of the mice increased really fast at the very beginning. So, well, that's the reason that the author decided to apply the log scale on the y-axis. Okay, and then if we want to go here, and we suspect that on the x-axis here, so at the very left side, and there are really a lot of countries, and then on the right half of the of this plot, and then we see probably there are only 20 20 or 25 countries on the right side, and then the rest of the countries are all on the left side. The problem is there are more less wealthy countries on the left side, but on the right side, then we don't have so many samples. And then the plan is we want to apply, number one, we want to do the scatter plot instead of the line chart, and number two, we want to apply the log scale on the x-axis. Okay, so well, this is the code to apply the log scale on the x-axis, and then you should get something like this. Well, the goal is, well, instead of squeezing all the less wealthy countries on the left corner, now we want to apply the log scale on the x-axis, and then we can distribute the samples a little bit better. So and then, well, as you can see, we have the x power 3 and the x power 4. So, well, we want to distribute the x-axis in a different way. And in this way, well, for the less wealthy countries, and they are a little bit farther away from each other. And then for the wealthy countries, then they will get closer to each other. Okay, so this is what we want to do. And go ahead and plug in the code. And if you finish, you should get something similar to this one. Okay, so go ahead and pause your video here and do the coding now. Okay, so if you are here, and I guess you have already finished the coding, and this is my solution, well, we are doing a scattered plot, and then we want to apply the log scale to the x-axis, and eventually at the very last, and we want to do a plot dot show, and then we show this image, right? And here are some of the questions. Well, if we see, after we apply the log scale, do you still see a positive correlation? And probably yes, right? Well, even though we apply the log scale, but still, well, we see as the GDP per capita on the x-axis increases, and then the value on the y-axis also increases. So there is still a positive correlation. So the if you're lucky enough, you're born in a wealthy country, and then you are expected to live longer, right? Okay, so let's see another one. Well, and now we are trying to find the population, and then population of the country and versus the life expectancy. Okay, population of the country versus the life expectancy, and then if you want to do a scatter plot again, and my question is, are we going to see some correlation here? Okay, so even before you do this plot, think about that. The population of the country versus the life expectancy. And you may think, if you are born in Luxembourg, for example, and that's a wealthy country, a small country, and then uh, the life expectancy is also very high. But there are also small but not so wealthy country. Well, and do we really have any correlation? And so first, try to make the plot, and number two, if you have the plot like this, and then try to interpret that. Try to explain and tell the story based on this plot. So go ahead and pause this video again, And after you get this visualization and think about that, how are you going to explain or tell a story based on this plot? Okay, so here is my code. Well, I'm doing a scatter plot with the population as the x-axis and the life expectancy as the y-axis. Okay, and then I found it is almost one line squeezed to the left side of this plot. And what does that mean? This means, well, for most of the countries, the population is not so big and they are really on the very left side of the x-axis. So for most of the countries, 90% of the countries, the population is kind of small. And for those countries with kind of small population, and what are the distribution of the life expectancy? We see some of them have 40, 50, 60. And then for some of them, they have 80, 70, right? What does that mean? This means it doesn't really matter it doesn't really matter. Well, if we have a big population or a small population, because the population of the country doesn't really have too much impact on the life expectancy. For a small country, you can have a very low life expectancy like 40, 50, or you can have a good expectancy like in 70 plus, 80 plus. So it's the life expectancy is not really related to the population of the country. Okay, and then what else? What else do you want to talk about? Do you see there are two samples on the right side? Okay, and then my question is, what are they? There are two countries. They both have big population. And then if you consider life expectancy 60, middle 60, and then a little bit higher than 70, what are those two countries? Well, I don't know if we have international students in our class, but they are India and China, right? And then if you consider the population of those two countries, and those two countries are not so bad. Well, and probably 50 years ago in India and in China, the life expectancy could be much, much lower. But now, I think both for India and China, and they are doing a okay-ish job at least. Okay, well, and that is the story I also want to tell, because when you are presenting a visualization, and then people will first try to see the trend, and then I talk about the trend, and the trend means there's no correlation or very minimal correlation between the life expectancy and the size of the population. And another thing people may see is, well, what are some of the outliers? And then I do want to highlight there are two outliers here. And then, by the way, you can also talk about this sample. What is this sample? That is the population. That is a country with a good population, not a super big population, but a big population. And then this country also did very well in the life expectancy. What is that country? Okay, I'm gonna leave this question to you, and probably you have to do some research and figure that out. And then that's also a good point of doing a little bit storytelling. Okay, and then that is the end of today's this lecture. And then well, here are some of the things you want to remember. When you have a time scale along the horizontal axis, and then doing a line plot connecting all the dots, well, that makes perfect sense. Okay, well, but if you don't want to connect the dots, you only want to show the distribution of the dots, and then doing a scatter, usually you don't lose too much. Well, in the temporal pattern, say the seasonality of the temperature or the water quality, and then you do want to connect all the samples, you want to do a line, but usually if you don't want to emphasize on the continuity of the sample, you don't have to do a line chart. And a lot of times I will say doing a scatter plot if it makes sense to you. Okay, and based on the distribution of the samples, and sometimes we do want to apply a different scale, for example a log scale to the x or to the y-axis, and just to have the samples redistribute a little bit to make the visualization look clearer to the audience. Okay, so those are some of the takeaways from this lecture. And remember, doing the coding and showing the visualization, well, that's good. Well, that's a coding skill, that's a technical skill. And remember how to tell a story to make the visualization look interesting. That is also an important soft skills for the data science people. You should also focus on that. You should also try to develop this skill in this course. Okay, so I will see you later.